Hey y'all, welcome back. Tonight's homework is an introduction into logarithms, and we'll start by just going back and forth between logarithmic and exponential forms of equations. So just to kind of clear up how we do that, if there's any equation that's written in this form, log with some base of a power equals an exponent, the number that's over here is the exponent, so when we rewrite it, that can be the exponent. The base is the base in both cases, and then this input into the logarithm is the output of the exponential function. Remember that these two functions, logarithms and exponential functions, are inverses, so their inputs and outputs are just reversed. And so you can kind of see here that the exponent and the power as the input and the output are flipped, whether we're talking about an exponential, down here's the exponential, and the logarithmic equation. So our first set of problems here is just going to be practicing rewriting these logarithmic equations as exponential ones. So in other words, we are going to use this format to try to rewrite what we have here. So if we've got log base 3 of 9 equals 2, then the base is 3, okay, the exponent is 2, and the power is 9. And when you write this equation, it should make sense. 3 squared is 9. And so, so there's our answer for number 1. We're just rewriting these logarithmic equations in exponential form. For number 2, the base is 4. The exponent, if I can move this so you can actually see it, is going to be 1. And the power is also 4. Again, we've got an equation here that is true. 4 to the first power is 4. And so if you try to rewrite this as an exponential equation and the equation just doesn't make any sense, like if I did like 1 to the 4th equals 4, then that means I did something wrong when I converted this. Here our base is 6, our exponent is 0, and 6 to the 0th power is 1. For number 4, we've got 7 as our base. The exponent is what the logarithm equals, so that's going to be 3. And the power is 343, and this is true. 7 cubed is 343. For number 5, our base is 3, our exponent is 2, and so our power is 9. 9 is a power of 3. Specifically, it's 3 squared. On number 6, we've got a negative exponent, so that's why we've got this fraction here in the parentheses. So our base is going to be 3. Exponent's going to be negative 1. And our power is 1/3. I'm going to have to type that out separately here. There's number 6. Number 7 says log base 4 of 16 equals 2. So in this case, our base is 4. Again, the base is the base in both cases. The exponent is 2, and the power is 16. 4 squared equals 16. Checks out, so we know we did this right. For number 8, our base is 9, our exponent is negative 2, and our power is 1 over 81. And yeah, that does actually check out. 9 to the negative 2nd power is 1 over 81. Really what it is it's 1 over 9 squared, and 9 squared is 81. For number 9, we do not see the base of the logarithm written, and so anytime you don't see anything written here, if it says log, then we're going to assume the base is 10. And 10 to the negative 3rd power is 1 over 1,000, or 1,000th. All right, so those were 9 problems where we're going from logarithmic to exponential form, but now we want to go from exponential form to logarithm form. So in other words, we're going the other way around. And so here we have 6 squared equals 36, and so if you want to write that as a logarithm, the base here is going to be 6. The power is 36 and the exponent is 2. So log base 6 of 36 is 2, and that's because 6 squared is 36. For number 11, we've got log base 12 of 1 is 0. And actually, this is always going to be true no matter what the base is. As long as it's a valid base, so you don't have something like negative or 0 or anything like that. But in most, in every valid case, if you've got a 1 in the argument here, then the logarithm is always going to equal 0, because anything to the 0th power is 1, as long as that anything is a positive number. Positive number. So number 12, we've got 16 to the negative first power is 1 over 16th. So our base is 16, the exponent is negative 1, and the power is 1/16. So I think what I'll do here, so that I can actually fit this in here, I'm just going to delete this, give myself a little bit of space, and type this 1/16 separately. So there we go, log base 16 of 1/16. Clearly I need a little bit more space here, but you can kind of get the gist here. Log base 16 of 1/16 is negative 1. And we have a similar problem down on number 13. And so just to speed things up a little bit, I'm going to copy and paste my answer for number 12 because I know it's going to be very, very similar. Well, I'm going to try to anyway. Copy, paste, there we go. Okay, but in this case, the base is 5. Okay, the exponent is negative 2, and the power is 1 over 25. For number 14, our base is 125. So I'm going to go back and actually steal this again. Log of the base, log base power equals exponent. So here we have log base 125 of our exponent, which is 2/3. So I'll come back to that. And then our power here is 25. So 125 to the 2/3 power is 25. Number 15 looks very similar to number 14. In fact, the answer will have the same sort of structure here. And so I'm going to copy and paste my answer from number 14 over to 15 and change the numbers so that they match what I actually have. So here the base is 49. The power is 7. And so the square root of 49 is 7. And so that's why we have log base 49 of 7 equals 1/2. Okay, when you raise something to the 1/2 power, that is equivalent to taking the square root of it. Number 16, we've got our power, which is 125. Our exponent's 3, my base is 5. So let's go ahead and fill all that in. Base is 5, power is 125. The exponent is 3. There's not really much more to it than that. That's it. Log base 5 of 125 is 3, and that's because 5 cubed is 125. For number 17, same kind of deal here. The base is 13. The power is 169, and the exponent is 2. Number 18 is going to have a fraction here, and you can see it's going to be kind of like number 14 and 15. So I'll just copy and paste that answer here and change the numbers as necessary. So we have log base 4, base is 4 here. of 1 over 64. So I'm actually going to leave some space here so that I can include that. This probably would have been better to copy number 13 versus number 15. That's okay, no big deal here. And this is going to equal negative 3. So let's say if we can't put that 1 over 64 over here. And our answer is going to look a lot better now. So log base 4 of 1 over 64 is negative 3, and that's because 4 to the negative third power is 1 over 64. And also, before I forget, let's put some boxes around these two answers over here. Okay, we've got just a few more of these where we're going from exponential form to logarithmic form. The next one, 10 to the negative third power, is 0.001, or 1,000th. So, well, let's try to copy and paste this. There we go. The base in this case is 10. Now, I would put 10 here, and I'm just going to put that now here temporarily, but you'll see what will happen. If you have got a base of 10, that is considered your common base. And so you don't typically write 10 there. You're going to just actually write nothing. So if you do not see a base written here, it is assumed to be 10. And so you're safe to just write log of 1,000th equals negative 3, and then we can assume the base to be 10. For number 20, we're going to have 81 to the 1/4 power equals 3. So 1/4, that's going to be our exponent here. So this is going to be kind of like what we have over here in 15. Just looking for like a similar style answer here so I don't have to retype everything. My base is 81. My power is 3, and my exponent is 1/4. So because the fourth root of 81 is 3, or 81 to the 1/4 power is 3, either way, we can say that log base 81 of 3 is 1/4. Number 21, very similar situation here. You can see how the structure of the problem number 21 is basically the same as number 20. So the base is 9. The power is 27. And the exponent is 3/2. All right, and that completes the first page. So far we're not really doing too much with these logarithms. We're just kind of we're starting just to get used to them and understanding the relationship that these exponential and logarithmic equations have to one another. These are what we're writing here are equivalent equations that once you get used to rewriting these will help once we start solving equations that involve exponential and logarithmic functions. Okay, this next section, you really could use a calculator to do this, but I'm going to suggest that you do not. Okay, I'm going to just challenge you to try to find these values without a calculator by thinking about what they mean. So, like this one, log base 4 of 16, what does that equal? Well, this equals the exponent 4 to some power equals 16, right? So this is really the question that we're trying to answer here, and hopefully you know that 4 squared is 16, so our answer here is 2. And so this question is really what you want to be asking yourself whenever you're trying to evaluate these without a calculator. I know that you get a calculator, but you'll understand these better if you force yourself to try to answer these without one. Here we've got 3 to some power is 81. And so that's some power. Let's see if we just multiply 3's. Let's see if we can get to 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So since I had to multiply 4 3's to get there, this thing is going to equal 4. 24 doesn't have the base explicitly stated, but as we talked about back here, number 19, and also just in class, if you do not see the base written, it is assumed to be 10. So this is really asking 10 to what power, not to the third power. Well, actually, it does end up being the third power, but 10 to what power is 1,000? And so we just want to keep multiplying 10 until we get to 1,000 and keep track of how many times we have to do that. And as I spoiled earlier, it is 3. Now, if you're dealing with these logs with base 10, a quick way of figuring out what that exponent needs to be is really just to count the zeros here. Notice there's 3 zeros here. That is 10 cubed. So like 10 to the, let's say, 5th power would have a 1 with 5 zeros and so forth. Number 25, the base is Euler's number E, and we want to know what power do I have to raise that to get to e to the 7th. Now, if I write it like this, it makes the answer so obvious, right? Like, obviously, it's got to be 7. But I think if you just if you overthink this one, it can make it a little bit more challenging. But really, if you just get in the habit of asking yourself, the base to what power gives me what's in the parentheses, sometimes these more complicated questions, or at least they seem more complicated, are actually easier. So you don't have to actually multiply anything. You can just obviously see that this has got to be 7. Log base 3 of 1 is asking the question 3 to what power is 1? And, well, 3, not just 3, but anything raised to the 0th power is 1. So this has got to equal 0. 5 to what power is 1/5? So this is kind of goes back to our last unit when we discussed exponent properties, and we said that whenever you raise something to a negative power, it's equal to 1 over that base with the positive power. So we don't actually see a power here, but it's just so it's to the first power. So that means that this thing will equal -1. 5 to the negative first power is 1 over 5. Remember that when you have a negative exponent, that indicates repeated division rather than repeated multiplication. So 5 to the -1 means you take 1 and divide by 5 once. 5 to the negative third power would be 1 over and then 5 times 5 times 5 on the denominator. Number 28, we are trying to answer the question 4 to what power is 4? And if you ever get a question like this where the base is the same as the power, then this thing will always just equal 1, because when you raise something to the first power, it doesn't change the value. So 4 to the first power is 4. Log of 10, this is another one kind of like, where did we have this? Number 24, where the base is not explicitly written, but when that happens, we assume it to be 10. So 10 to what power is 10? And this is going to be the same answer as number 28. It's just going to be 1. Number 30, we've got log base 36 of 6. Now, this might throw you off at first because our power is smaller than our base. So 36 to what power is 6? Now, you might notice that the square root of 36 is 6. Whenever you take the square root of a number, that is equivalent to raising it to the 1/2 power, and that's going to be our answer for number 30. I think we had a couple questions earlier that had to do with this where the power is smaller than the base. I want to say, let's just scroll up a little bit. Yeah, here's a couple of examples. Number 20, you can see the power is smaller than the base. This is going to happen anytime you've got this fractional power up here. I want to say there was another one like that too. Yeah, you can see 14, 15, the power is smaller than the base. Anytime you raise a base to an exponent that is smaller than 1, and we'll just say still greater than 0, then it will shrink that number. And so the square root of 36 is 6, therefore 36 to the 1/2 power is 6. Now that brings us to our last section here, where we're trying to rewrite these equations as a means to solve for x. Now, these solving problems, in the big scheme of things, are going to be pretty straightforward. They're going to be pretty easy, quite frankly. You only have to do one step where you just do what we did up here, or maybe in the next section where we rewrite logarithms as exponential equations and vice versa. And x will just sort of solve itself after doing that. So yeah, that's what we're going to do here. This is going to lead into more complicated equations in a future homework and a future lesson, but that's coming up pretty soon. So you definitely want to make sure you have these kinds of problems down pretty well. So 31, we want to rewrite this as an exponential equation. So 3 squared equals x. And so since 3 squared is 9, we can say that x equals 9. So hopefully you can see, yeah, this problem kind of just solved itself. Once we rewrote it, x was already isolated. Number 32, we've got our base is x, so x squared equals 81. Hopefully you just know this off the top of your head. If not, you could just take the square root of both sides, and we get x equals 9. You might wonder why we are not going to also include negative 9, because negative 9 squared is 81. And that's because that the base of a logarithm cannot be negative. And that kind of goes back to just the definition of a logarithm. A logarithm is the inverse of an exponential function, and by definition, exponential functions cannot have negative bases. So you can't have negative bases on these logarithms either. So we're going to disregard the negative 9 solution here and just chalk it up to being extraneous, and we'll just go with the positive 9. For number 33, we've got 25 to the 3/2 power equals x. Okay, this one's a little trickier, but I'll try to take this in 2 steps. So first I'll take the half power of 25. So as we stated over here, whenever you raise something to 1/2 power, that's equivalent to taking the square root of it. So the square root of 25 is 5. Now that I only did 1/2, okay, but this was 3/2, so we still need to raise this to the 3rd power. And 5 cubed, 5 times 5 times 5 is going to be 125. So x is 125. For number 34, the base is not explicitly written, but it does say natural log, so we know that the base has to be Euler's number. And so Euler's number squared equals x, and that is that's it, right? X is just e squared. We cannot simplify this any further. So that's just our answer. Okay, number 35, e to the x equals 10. So we're going to rewrite this as a logarithm. Normally we would write log base e, or log base whatever the base is. But in the case of Euler's number, if this is your base, you're not going to write log base e. Instead, you're going to write natural log. So the natural log of 10 equals x, and we're done. Like I said at the beginning, these equations, once you rewrite them, kind of solve themselves. But they will, once you get used to these, we can do some of the more complicated ones. Number 36, 3 to what power is 7? We know 7 is not a power of 3, so this is going to be some decimal or some irrational number. And so we'll rewrite this using a logarithm. Log base 3 of 7 equals x, and that's just it. There's nothing really to do after that because x is already isolated. It's just log base 3 of 7. You could use a calculator to estimate the decimal, but that's not really necessary here. Number 37, 10 to what power is 12? So we've got log base 10, and since it's base 10, I'm not actually going to write the 10. Log of 12 is x, and there you go. That's our answer. Number 38, e to what power is pi? Kind of a weird problem here. Pi is a little bit bigger than e, so it's definitely got to be bigger than 1, but in order to get the exact value, we need to invert this equation. So log base e is natural log of pi is x. So yeah, e raised to the power of natural log of pi equals pi. And that about wraps it up for tonight's homework. We're just kind of scratching the surface here as far as logarithms go. Next time we will look at different properties of logarithms, and ultimately we want to get to a place where we can use all the properties that you're going to learn to solve equations. So this little solving section is just a little tiny preview of how to invert equations in order to isolate x. So other than that, y'all, thanks for watching, and you have a great day.